represent CADTrak Engineering. So we're, I guess, either the first or one of multiple vendors that provide services to this this group of people, perhaps. So we do primarily mechanical systems development and research and development, technology development. My background was as a JPL employee at NASA, and so I worked on the Cassini spacecraft and the Mars program, and so now I'm work at a small business, kind of like some of you, and I've had to recalibrate. And it's interesting. So I have sort of a story from being back at JPL, which was, so there was this myth at JPL that because the government is known for everything costing millions of dollars, right, for the littlest thing. There was this myth of the engineer that was called into his manager's office, and his project manager has his widget on the table, and he says, I can't believe you did this. Tell me, And he said, this thing's gold plated, and the engineer says, well, I would have made it out of solid gold, but it'd been too heavy. So that's a little JPL humor, NASA humor. So, anyways, now I understand the life in the real world and designing to cost. And so anyway, so let's see. Like I said, we primarily do mechanical systems development. We have a number of customers I'll get to in a second, but we can do aerospace structures and mechanisms development, robotics, fluid systems, electronic packaging, and automation control. So some of our capabilities, we use primarily SolidWorks, and we can do mechanical design, stress, thermal, dynamics, and CFD analysis, which might be applicable to some of the stuff you're working on. Some of our customers, we've done an SBIR for NASA. I'll talk a little bit more about that in a minute. One for the Department of Energy. We do some fluid dynamics work for M4 there in Long Beach. Modular wind, we helped them develop we're working on a new generation wind turbine blade, so those big 200-meter long blades. This company is developing a way of constructing those like they do airplane wings. Okay, until today, the state of the art in those big wind turbine blades was no more advanced than the way they make a surfboard. Big foam with lots of fiberglass around it. And so these guys are innovating on that. Clean Filtration Technologies is a water filtration company that I had a hand in. Pressure vessel design, seals, things that might be applicable to some of the stuff you're doing. And then, of course, we've spoken with Team Phoenicia about doing some mass optimization and some CFD for their work. And this is all going to be really short. I just wanted to introduce us. And I thought I'd mention a couple of the interesting projects we're doing. So this is one of the technologies that we're commercializing right now. It's a water filtration system. I think that was mentioned earlier, but it's sort of in line with the whole talk of markets and knowing where your market is. So when somebody says they're developing a water filtration, I hope they're not developing a water filtration system for the home user or a pump to. It's like there's millions of those. There's millions of people trying to do that. You got to really find your niche in the market. And so, like for example, what we do is an industrial wastewater streams. Right? It's very specific. We got funding from the Department of Energy because it's applicable to the oil and gas industry, the biofuel industry. So we helped innovate this material, which may even have some applications in your industry. And so this looks like an ordinary sheet metal, but when I shine a flashlight through it, you can see right through it, right? So it's a nickel membrane that has 10 micron pores in it, and it's so mirror smooth that we can clean it by just wiping a brush over it or wiping a wiper over it. So we're commercializing this technology right now along with our filter. And one of the, I'm just going to turn off light for a second so you can see. So this is a cross section here of the material, and I've always noticed that those pores look a lot like nozzles on a rocket engine, or the nozzles on an atomizer, you know. And before I got involved with this project, I always envisioned using this material as, you know, part of the part of the rocket engine that, you know, creates the droplets of fuel. So if you want to talk about this stuff in the future, we can. I know nothing about rocket technology, so.
It's called an injector.
An injector, thank you. I just learned that the other day. Okay, so another project that we've got going is a something for JPL, working back there. It's for the Mars exploration program. This is a robotic exploration technology. And so, I won't bother turning the lights off. So for a future Mars sample return mission, they're going to drive around with a rover. It could be Mars, it could be the moon, it could be an asteroid. They're going to drive around and drill into the rocks and collect core samples. Okay, and one of the big things is nobody knows how to take those core samples and encapsulate them so that when they fly them back, they don't crumble and fall apart, or if there's volatiles in there, they don't go away. And so we've developed a quite ingenious, and I can say that because I didn't actually come up with the idea, one of my employees did, but it's a way we basically just use heat shrink tubing on the inside of a core drill bit, with heaters on the drill bit. You drill into a rock, you turn on the heater, it shrinks the heat shrink tubing around the sample, and then you pull out a plug of encapsulated rock. Brilliant. Wish I'd thought of it. So that's something we're doing for NASA JPL. And then finally something that just recently got involved with, and Sean and I have been talking about this, which is the PhoneSat guys over at Ames. So I'm sure everybody knows about, but you know, they're putting a phone in an Android phone in a CubeSat and launching it up into space and demonstrating that commercial technology is good for that kind of thing. And so we went over there and said, what could we do to help? How could we be a part of it? And one of the things I said was, nobody, there really isn't a good, well, first of all, they're open sourcing their project. There really isn't a good open source ground station to communicate with small sats. And so what we need is a small S-band ground station, let's say a 3-meter dish, that could be part of a network. And we would like you to open source your design so somebody else could build the gimbal, or they know which transceiver to use. And so we're going to start an open source project to develop an S-band ground station, high gain, so it's in comparison to the the 1-meter dishes that you can pretty easily point. We're going to do a 3-meter dish, and if anybody wants to be a part of that, we'll start. We're going to get started with the web page, and then Sean and I know we've been talking about it.
I want to be part.
Yeah, and so I thought I'd throw that out there, and maybe to provide services to one of your customers one day. And I think that's about it. We're located up in Marin County, so we can do, like I said, mechanical systems development. And if there's a particular skill set you need that in aerospace that we don't have, but you're looking for somebody, give me a call. Things like for your development, air elasticity, or hypersonic analysis. I know the guys that can. I've worked for them on some other projects, and so we'll be happy to set you up. If we can't do it, we'll give you somebody that can.
Yeah, I'm really interested in your S-band amplifier, or your comm station. We'd be happy to help out or contribute if we can.
Okay.
What kind of things are you guys looking for?
Well, at this point, I don't know. Well, so what I forgot to mention was the innovation that I came up with, which was, so they decided that you could put a phone in a satellite. What I figured out is I could point a satellite dish with a phone, right? If I take my iPhone and bolt it to the front of that satellite dish with a single app and 2 motor controllers, I can log into this phone and give it the the Keplerian parameters of the satellite, and my phone could point that satellite dish. It's got a magnetometer, it's got inclinometers, it's got GPS. It knows where it is, it knows where the satellite is. So, you know, we're going to put a cradle on the front of this.
So once they link up, then they can tell it to readjust. The satellite can tell it to readjust the antenna to track it.
Basically, well, that's one of the other innovations we'd like to work on, which is now so in small sats, you want to find your satellite, you want to refine the orbit so you can tell people where to look. Usually it takes multiple passes, you know, and they'll do it with a beacon, right? So what we want to do is develop something on our dish that uses some form of, you know, say, smart tracking with some hardware, and you know, so if we can point it just, you know, within a few degrees, that we could perhaps refine the orbit parameters in one pass. You know, that way you can get data quicker. You can get data on the second pass versus, you know, waiting a day while you figure out where the thing is. So programming for the phone, we could use help with that. Calm people that understand the transceiver, all that stuff. So you just email me, and we'll once we get online, we'll start talking about it. This is going to be a fun project.
Pop it back to the next slide with your contact info.
My contact info. And you can take one of my business cards too. So yeah, we're in Marin County, up in beautiful San Anselmo, which is north of San Francisco by about 20 minutes. And it's quite a trek to get down here on a weekly or monthly basis, but I do it because it's there's no aerospace industry to really speak of up there. So this type of work all involves the South Bay here in the valley.
The amazing thing is the number of good aerospace people there are up there.
Yeah.
It's kind of shocking, actually.
Yeah. Well, they always say, was it walk to fun, drive to work?
Yeah.
So. Any other questions for me? No? Okay, that was it. Thank you.
Oh.